What's up, geeks, and welcome to the channel. In the world of microservices, one of the first challenges we'll run into is managing how our front-end or clients communicate with all those individual back-end services. To simulate this, imagine we're building a simple system with two back-end services, a user service running on one port and an order service on another. Each service has its own REST endpoint, one returning a list of users and the other returning a list of orders. To fetch this data, our front end needs to directly call each service using their specific URLs and ports. That might seem fine at first, but it quickly becomes a hassle. The front end is tightly coupled to the back end setup. It needs to know exactly where each service lives, and if we decide to change a port or scale our services differently, we'd have to inform the client too, which is far from ideal. On top of that, applying consistent security policies across all our services becomes tricky and fragmented. This setup may work in small demos, but it's not sustainable for real-world scalable applications. Not to mention, we need to deal with multiple authentication flows, manage resource sharing for each service, and handle concerns like logging, rate limiting, and set up retries for each individual microservice. It becomes messy, fast. That's where Spring Cloud Gateway comes in. It acts as a single, unified entry point for all client requests. Our front-end talks to one place, and the gateway takes care of routing those calls to the appropriate back-end service. This simplifies the front-end logic tremendously and centralizes important features like path rewrites, load balancing, security, and logging. So, instead of calling different ports for users and orders, everything flows through one neat address, and the gateway handles the rest behind the scenes. It's clean, efficient, and makes our architecture much easier to scale and secure. Before writing code, it's worth understanding what powers Spring Cloud Gateway under the hood. Spring Cloud Gateway is built on top of Spring WebFlux, a reactive non-blocking web framework introduced in Spring 5. WebFlux is designed for handling massive amounts of concurrent requests efficiently using far fewer resources compared to traditional blocking approaches. Because of its reactive nature, the gateway can handle thousands of incoming requests using minimal threads, making it lightweight and highly scalable. Even though WebFlux is reactive, the beauty of Spring Cloud Gateway is that it doesn't require our backend services to be reactive too. It can forward requests to traditional blocking services just as easily. This makes it a powerful and flexible choice for modern microservice architecture, whether we're fully reactive or just getting started. Okay, now before building the gateway, let's prepare our microservices and start with the user service. We can use Spring Initializer to create this service. All we need is the Spring Web dependency and we are good to go. Let's open the generated project and create a simple controller with one endpoint, the user's endpoint. For now, it returns a dummy list of usernames to simulate user data. This example keeps things simple in order to better demonstrate the routing behavior of our gateway. In the application.properties file, go ahead and set the server.port property to 8081. This configures the user service to run on this port separate from the other services and the gateway. The order service will be very similar to the one we just created. The Spring Initializer inputs are exactly the same as we can see. We'll also define another basic REST controller that responds with a list of orders. Again, we're using static data just to demonstrate request forwarding through the gateway. In the properties file, we'll set the server.port to be 8082. This makes the order service run on it, making both services operate independently on different ports. Now, to illustrate the problem, using Postman, if we want to retrieve the list of users or orders, we will have to call each service on its corresponding port. This not only requires the client to be aware of all the ports of our service, but also exposes our microservices' internal API to the clients of our application. To solve this, let's create a gateway. To do that, we will use Spring Initializer as well and add the Spring Reactive Web and Reactive Gateway dependencies. Once the project is ready, go ahead and navigate to its properties file. For readability purposes, I personally prefer the YAML format, but feel free to stick with the properties extension if you want. Okay, here, we'll set the server port property to 8080, and the Cloud Gateway configuration under it defines two routes. The first route has an identifier of user-service and forwards any path starting with users to localhost 8081. The second route, order service, forwards any path starting with orders to port 8082. These paths are predicates that act like a rule or condition to match incoming requests. If the request path matches, the route is activated. Now, we can go ahead and test the gateway. As we can see, any request starting with users to 8080 will correctly return results since it forwarded our request to port 8081. Same goes for the orders API. We just built a gateway for our services. Okay, even though we have a gateway, our paths are still exposed. The client can still access our internal services simply by switching the port of the API call. What we really want is to keep our internal paths hidden and consistent. To do that, let's have our backend expect something like API/v1/users while exposing a simpler, cleaner URL like users to the outside world. This is where the RewritePath filter comes in handy. It allows us to intercept incoming requests at the gateway and modify the request path before it's forwarded to the backend service. So, if a client sends a request to the user's API, the gateway will rewrite that to /v1/users and forward it to the appropriate service. This way, we get the best of both worlds. Our front end works with clean and user-friendly paths, while our back end continues using structured, versioned routes. It's especially useful if we're reorganizing internal routes or planning for versioning, but don't want to impact the external API consumers. So far, we've set the stage with the basics of Spring Cloud Gateway, from understanding the need for a gateway to setting up path rewrites for cleaner and more secure API. But this is just the beginning. In upcoming videos of this series, we'll dive deeper into filters and how to extend the gateway's behavior to fit more advanced scenarios. And that's it for this video. I hope it was helpful. Thank you guys for watching, take care, and I will see you in the next one.